Hey, calculus class, second video for this week number 5. And we pick up with a little bit different scenario. This looks really complicated. We're going to make it really easy for you. And as you notice, we have a polynomial on top and we have an expression on the bottom. And one way in which we handle that situation is very simple. If you have a larger degree on the top than you do on the bottom, go ahead and just divide that. If you notice, I get the integral of 3x squared over x plus 4x over x minus 2 over x. You can simply just rewrite as a fraction over each denominator, then simplify it. Notice I have not taken the antiderivative yet. I still have my integral sign. I have 3x plus 4 minus 2 over x dx. This now becomes an incredibly simple integral to determine. If you notice, the antiderivative of 3x is just 3x squared over 2. The antiderivative of 4 is 4x, and the antiderivative of 2 over x is 2 natural log of x, plus c. Don't forget your constant on the end there. So it becomes pretty straightforward right away. As soon as we recognize it, you can divide through. So that's a little trick. Sorry, my markers are starting to dry out. Helpful tip for markers: if you hand them upside down, it tends to drain all the ink towards the bottom. So it really helps as you try to conserve on your markers. I'm sure you guys are all learning how to do that. So what about the next one? Well, number 8 is just slightly different here. We've got notice in this situation that the top and the bottom have the same degree. And in this situation, you really have two options. Number one, you can use substitution. It gets a little bit messy, but I think that the best option is simply to just divide. And I'm going to take you back to a process that you use when you divide polynomials. X minus 1 goes into x plus 1. And when we divided that, again, I'm just rewriting this. That's all I'm doing at this time. It may seem like a lot of work, but I really think it's a good option. I really do. What do you multiply x by to get x? 1. Multiply that back through, and you get x minus 1. Subtract, and we get 2. So that means that the remainder is 2. The way that we write the remainder is plus 2 over x minus 1. So you put the 2 over that guy. So you covered that in algebra 2 and pre-calculus. Hopefully you remember that division skill. If you don't, maybe go find a video on the web and watch how to do that again. But this is my new expression, and that's easy to find the antiderivative of. So I have 1 plus 2 over x minus 1 dx. Again, these two expressions are in fact the same. And the antiderivative of 1 is just x. The antiderivative of 2 over x minus 1, that's an easy substitution situation. If you look at the antiderivative of 2 over x minus 1 dx, we would say that u is equal to x minus 1, so du is equal to dx. I don't have just dx, I have 2 dx. So 2 du is equal to 2 dx. I have my substitution, 2 integral 1 over u du. And notice the antiderivative of 1 over u is the natural log of u. So I get 2 natural log of, my substitution was x minus 1. So what's the antiderivative of that? It's 2 natural log of x minus 1 plus a constant. And after a while, you'll start to recognize certain patterns and relationships develop. You'll be able to look at that antiderivative and see right away, it's 2 natural log of x minus 1. If there was a 4x minus 1, then you come up with a 1/4 in that process. That would change things, but sometimes it's pretty easy to then look at it. So when I got it to here, I was able to see the antiderivative right away, and you're going to come about those situations as well. So 2 more problems, and as we do these 2, we are going to look at definite integrals, where we actually perform an evaluation. And so I'm going to look at the definite integral, 5 to 8, of 2 over x minus 3 dx. So now you come up with an exact value because you have bounds. Well, I need to find the antiderivative of that. Substitution, u is equal to x minus 3. Du is equal to just dx. Because I have dx and here I have a 2, I will go 2 du is equal to 2 dx. So now I have my substitution. Integral 2 du. Okay? And the integral in this situation is going to be of, the 2 is gone, the dx is gone, so it's 1 over u. I find that antiderivative. And the antiderivative of 1 over u is natural log of u. And u is x minus 3. And I have my 2. And now I'm going to put my bounds back there, 8 and 5. So that's what I determined. The natural log of x minus 3 times 2 from 8 to 5. If I plug in 8, I get 2 natural log of 8 minus 3 is 5. Minus 2 times, and what we do here is you plug in the 5 and you get 2. So natural log of 2. Now, we don't actually write the answer that way in calculus. First of all, you could factor out a 2, and you get the natural log of 5 minus the natural log of 2. But there's even still another way to rewrite that. And I'm kind of giving a little bit of a pause here to see if anybody here catches it on it. But the fact is that you can take subtraction of 2 logarithms on the same base. Notice natural log has a base of e. These are the same bases. If you have subtraction, you can rewrite as division. And so you get 2 times the natural log of 5 halves. And that's how you really want to write that final answer. Some of you remember that you could actually move the 2 up here and square both pieces. This would be the same as the natural log of 25 over 4. Books would really have either answer. The AP exam, any type of college professor would really have either answer here. Nobody would really actually leave it like that. This is much more of a simpler form. So take that into consideration. It kind of brings you back a little bit. I realize if I make the lessons too easy, then nobody will ask me for help. So if I, don't want to have any friends, then I make easy videos. But hopefully after this week, I made it a little bit more challenging, and maybe I'll have a friend or two that reaches out to me. So last example, we're going from problem number 10. E to the x. Sometimes I wonder if other people are watching our videos and what they think of me. I know you guys hopefully laugh from time to time. Like if I say I, Lexi right now I'm going I. If I say slap on an integral, Sydney and Sam, you're slapping, exactly. Wilner, you're giving a high five and back there, I got you. So, it's all good. I don't know if everybody else understands their humor, but that's okay. Let's look at this. You've actually done a problem very similar to this before. I've tried to build in problems throughout the year to set you up for different times. And we want to look at that antiderivative. The question is u equal to e to the x, or is u equal to e to the x minus 1? And the answer is u is e to the x minus 1, because the derivative of this gives me that. The derivative of this does not give me all of that. So therefore, u is equal to e to the x minus 1. Du is equal to e to the x dx, which I have an e to the x dx right there. So that makes my substitution quite simple. I have an integral, and I have du, and in its place, what do I have left? Well, this is gone, so I'm left with 1 over u. And the antiderivative of 1 over u is the natural log of u, which is e to the x minus 1. And we're going to evaluate that at 4 and at 2. So we just go ahead and plug in 4, we plug in 2. So we get the natural log of e to the 4th minus 1 minus the natural log of e squared minus 1. What do we do with that? Well, you can see the subtraction and natural log, same basis, so therefore we can write it as division. Natural log of e to the 4th minus 1 over e squared minus 1. So is that it? fact is that the top factors. Natural log of e squared minus 1 times e squared plus 1 over e squared minus 1. You can see that the top, in fact, does factor to e squared minus 1 and e squared plus 1. Those will cancel. I get the natural log of e squared plus 1. Do you have to write plus c? No, you don't, because this is a definite integral. Okay, if it's bounded, there's no plus c. This is an exact answer. It's a great answer. And yeah, that takes you through 10 problems. A nice worksheet to work through. You're going to see answers posted as well. I'd love for it if you as you work through it, work through the problem. And after you work through a few problems, then go ahead and check the answer key. Don't have the answer key up as you do your homework. It's really not good practice. You really don't know it that well. I just helped my son change the oil for the first time yesterday. So he's 5th grade, and I want him to get to know the car. He changed the oil, and it worked fine. But the fact is that when I know he's actually ready to do this on his own is when he can do it without me there. And I'll eventually come back and check on him, see how he's doing. But if I'm constantly there reminding him, then he probably doesn't know how to do it very well. Same thing with you. When you're looking at how to do this stuff, try not to just follow on the answer key. It's not really a good idea if you truly want to know this stuff. And then when you got one, even if you're able to figure out with the answer key, if you're just struggling with it a little bit, like how did that happen, or what would be the right thing to think about before I start that problem, reach out to me. I'd love to be able to sit and visit with you and do some math together. It always makes my week a lot better. Miss you guys. Love you. Take care. We'll talk to you soon.